Up next, we have our TRL panel, Takeoff, Reentry, and Landing. Our moderator will be Bruce Pittman, Chief Systems Engineer of NASA Space Portal Office.
Thank you. So can I get the panel up here? Nope. Hi, how are you? Hey, Tom. Okay. So, well, thank you. I know we're at the after lunch on the last day, so we'll try very hard to keep everybody amused and awake, including us. So I just wanted, I'll make some opening remarks, but just let me introduce the panel, and then we'll go through and we'll talk. I'll ask them to introduce themselves in more detail and give a little bit of background about what they're up to, and in terms of this takeoff ready. So again, we were talking about acronyms before, you know, the dreaded TLA. Well, we have TRL here, and this is a little bit of a play on words because for those of us that are true nerds, we know that TRL stands for technological readiness level, and all that. So this takeoff, reentry, and LEO I thought was very, very humorous. Don't necessarily understand it, but it's humorous. So let's start off from the far end there. Tom Martin is the senior manager for DoD and IC. I'm sure he can explain that what is, and commercial launch strategy business for Aerojet Rocketdyne. And they're local here in, I don't know if you're in Sacramento, but I remember from my younger days that Aerojet was in Sacramento. Next to him is Natalya Bailey. She's the CEO and founder of Accion. Did I pronounce that right? And she's got quite a fascinating background and everything. For a young person, she's really quite accomplished and all that. Had a chance to talk with her last year on the bus, I think, going to the museum. Next to her is Ron Goedendorp. Did I get that right? I'm sure you never have any problem with that. And he's the vice president of space operations for NanoRacks. I'm sure most of you have heard of that company before, but that's kind of a fascinating success story. And then finally, next to me is AC Charania. He's the manager of advanced programs at a little company you may have heard of called Blue Origin. You know, so we've got this great panel put together, and I've put together hopefully what will be some intriguing questions. Could we put up that first slide that, excuse me, that I asked for? So I wanted to provide a little historical perspective for this to remind us kind of where this all came from. And so, again, how seeds that are planted today can sprout in the future and sometimes in unexpected ways. So up on the top there is 2 summer studies that were done. This was a part of a NASA program called the NASA Summer Faculty Program that NASA was running back in the 70s. So the one on the left there, the Space Settlement Summer Study, was done in 1975 at NASA Ames and at Stanford University. And it had about 24, mostly faculty, but some graduate students as well. And one of the guys that was one of the directors of that was a guy named Gerard O'Neill. You may have heard of him. And he's the guy that wrote the book down there on the bottom, The High Frontier, that excited a lot of people, I think including your boss, to get started down this road. And then in 2 years later, in 1977, they did a deeper dive into some of these with space settlements and space resources, where they actually looked at some of the things like life support and food and you know, building materials and all that, and they did a deeper dive. All of these things are available online. It's funny, in the early days, I used to have boxes in my office, and then somebody kind of swiped my last copy of the Space Settlement book, and I had to go out and buy it on Amazon, and it cost me $75. So, so things that are free now can be valuable in the future. So I just wanted to kind of remind you that things don't always go the way you had planned. Some of us really were hoping that we would be further along by now, but we are making progress, and we're finally at that. And I hesitate to say this because it's an overused term, but I really do think we're at the tipping point here where we've got enough momentum, we've got enough technology, we've got enough momentum, going forward that I think we're going to make it this time. So, knock on vinyl or whatever. Hopefully, this is going to be our decade here, where we really make this come true. And it helps to have some of the richest people on Earth saying that this is one of their goals. And I'm gonna come back to a question on that in just a minute. So why don't we go down the row here, starting with you, Tom, and just if you could introduce yourself a little bit and kind of provide a little context on your company and what role you play in all this.
Sure. My name's Tom Martin. I work for Aerojet Rocketdyne. Hopefully some of you have heard of the many companies that now represent Aerojet Rocketdyne. First, let me assure you that I am most definitely a space fan, a space advocate, since reading Carl Sagan's Cosmos and being particularly fascinated by his concepts for interstellar travel. Went to school for rocket propulsion, have been in the space business my entire career and plan to stay here. I'm also a very skeptical person and not very daring, which is why I'm not a venture out there with my own space business, so I commend everybody who's got the guts to do that. Aerojet Rocketdyne, in case you don't know, we basically build rocket propulsion from the littlest monoprop thrusters up through the largest liquid hydrogen-fueled rocket engines, the RS-68. We've been involved in the launch of every astronaut from the U.S. Hopefully we'll keep doing that. Our propulsion has visited every planet, including Pluto. We've done nuclear reactors in space. We've done nuclear thermal propulsion. And we actually did the power system that's keeping the lights on up at the International Space Station. So we are all over the space community. And where we're at right now, I think our company is in an interesting position because we're not a big prime, we're not a Boeing or a Lockheed. We don't, quote, control our own destiny. We're not a vertically integrated company like where Blue Origin and SpaceX are headed, and we're most definitely not, an agile small startup. So we find ourselves in a very interesting position in where, as a company, we go within this market space, and we've had to look very much vertically, up and down the value chain to say where as a company do we want to head. And I think we've made some observations based on that. I think space is a very tough business to be in, fundamentally because of where we want to do business, which is space. That means that any good idea has to go through a whole lot of effort to actually get up there, work, and come back. And I see the biggest challenges, all these technologies are really interesting, but what it takes to get it up there, it really takes the entire community and an entire infrastructure to get something going 18,000 miles an hour and survive. That we all, I think we have to do it together. I think you're right that we're very much at a tipping point, but it's also possible that it could tip the other way. And I think the sense I get is we've got to be really realistic about the long-term vision, but really focused on making money in the near term so that the investment keeps coming in. From a launch perspective, it's really not about pushing the performance. We know the thermodynamic cycles. We know the combustion physics. It's about getting the cost out, and that's where we're looking. My company and others are looking at the technology, the manufacturing, to reduce the cost. And this renewed emphasis on reusability, I think maybe it's really going to happen economically this time. But I would caution, our company, was involved in obviously the space shuttle and the space shuttle main engine. So we've got a huge amount of experience with reusability, and we learned a whole lot through that. And there's a big difference between reusing something 1 or 2 times and truly having a system that is reusable 50, 100 times, that really makes the economics hard. But I'm confident that we can get there. We're involved in activities that hopefully will push this forward, and I'm excited about the future.
Natalya?
Sure. So Natalya Bailey. Oh, good. I have slides. Accion Systems. Can you reach that clicker right there? Thanks. This is actually my second space propulsion startup. So founded one previously. It was a microchemical rocket aimed at doing dedicated launch for small satellites, and that kind of imploded. I think the idea is still interesting, but then I was doing my graduate work at MIT, and we were working on a new type of liquid propellant ion engine, and turned out that one had legs also. So we spun Accion out in 2014, really with the vision of being, the new in-space propulsion company. So spun out in 2014. We've done a hybrid model of venture capital and DoD funding. We've launched the technology a couple times into space, so we know it works there. And then Accion, we're gearing up to deliver some of our first flight hardware as well coming up. So we can get to the interesting stuff. Flagship product, stick these thruster chips on the propellant supply system and those onto the power electronics, and the whole thing's about 1U and provides roughly 1,000 meters per second delta V in various configurations for various sizes of satellites. So we, I mentioned in space propulsion company, so we care a lot about LEO. Once you're there, phasing out your satellites, staying in LEO, getting out of LEO at the end of your lifetime, any other maneuvers there, and eventually GEO and interplanetary missions as well. But we're ultimately a little bit agnostic as far as which applications and segments we serve, because we're part of the supply chain. But that said, we are a young startup, and so we have to be pretty thoughtful about who we, what, I don't know the saying, what horse we hitch our wagon to, or something like that. We have to be focused and choose early partners that will be around for the long term. So we do a lot of thinking about where we see various sectors going, and the people in them. So I sort of mentioned this. So keeping satellites in LEO or very LEO, phasing out constellations, raising orbits, and deorbiting. But we also want to be around when we're doing stuff like this in space. So, that will look like keeping fuel depots and stations in position, or allowing spacecraft to reach them and depart from them, harvesting resources from other planetary bodies and things, maintaining the integrity of these orbits, getting rid of debris and things like that, and then construction and manufacturing. With that, looking forward to the panel.
First off, thank you for inviting me up here. I love that the title of the event is Convergence, and I see a lot of my customers and partners out there, you, and as the VP of Space Opportunities for NanoRacks, I get a lot of interesting ideas working out here in Silicon Valley. And furthering those ideas or moving them quickly from an infancy stage, early stage companies, just a notion and testing the market, it's transitive and it's transforming at the same time. But no one of these companies that approaches NanoRacks, or I think any of us here in the room, can do this alone. We need to find ways to work together, hence the notion that this convergence works, right? Again, I point out to partners and customers out in the audience who have helped us get to where we are at NanoRacks. NanoRacks is not just a CubeSat delivery company, but we do much more on the side of enabling microgravity research, but primarily what we do is we enable our customers and partners to do things that they wouldn't be able to do alone. And I think that is what the ecosystem and what convergence represents. On the thought of reuse, right, we've recently announced that we're intending to repurpose the upper stage of a Centaur rocket as a commercial element of the space station, and perhaps that will fly independently as a fully automated manufacturing facility in space. So finding methods for reuse, Blue Origin reusing rockets, SpaceX reusing rockets, finding reuse is a way to begin to lower costs for space access and enabling our customers to do things that they couldn't do before at a lower price point that makes space and NewSpace commercial activity very accessible. And with that, look forward to speaking on the panel. Go ahead.
So good afternoon, everyone. Very happy to see fellow advocates, champions of NewSpace here. So my name is AC Charania. I work at Blue Origin, and I manage some of our advanced program activity over at Blue. A little bit about my background. So I've been involved in NewSpace, I think, since I graduated from Georgia Tech. So I worked initially at a company called SpaceWorks in Atlanta, where we did a lot of advanced concepts, but also international space. We also spun out companies, including Generation Orbit and Terminal Velocity Aerospace. Then I left to join Virgin Galactic, and specifically the Launcher One program, and then recently joined Blue Origin. So it's a very exciting time. I think I personally, in my own career, have felt the evolution, expansion, growth of the NewSpace community, and it's been very exciting. And it's even more exciting today than it's ever been, as Bruce mentioned. So this is a picture of space that hopefully many of us will see in the near future. So this is taken from one of our vehicles, and the vision for Blue Origin is really to enable millions of people to live and work in space. And I think we tell that to ourselves, and it informs the systems, programs, architecture, scenarios, technologies that we're looking at. Let's see, next slide, or I don't know if I can. So it's a pretty exciting time, and one of the systems we're developing is New Shepard, which is a suborbital space transport system that leverages a LOX hydrogen booster with a crew capsule. So we have flown this vehicle several times to space. We are now producing additional serial numbers of this vehicle and look forward to additional test flights leading to first human flights here shortly. We are also offering this service for suborbital research payloads. Please see my colleague, Erica Wagner, who's here, if you're interested in that capability. So it's a pretty exciting time, and we can now see the systems and vehicles that we've been maturing slowly coming online and slowly here ready for operational service. Let's see. And so this is the inside of the New Shepard crew capsule. We had a mock-up of this capsule at the Space Symposium earlier this year, which was very well received, and we had many people at the symposium come and sit in the seats. Hopefully some of my panelists were able to do that. It's pretty exciting. Some of the largest windows, or the largest windows in the history of any capsule. So we're pretty excited about the system, and it's pretty exciting not only for the people that will go up, but also the payloads. And so, it's very exciting to enable research payloads that push the TRL, so to speak, using this panel's nomenclature, of the various technologies that people want to get into space, or a unique microgravity time that the New Shepard vehicle can enable. We're also building larger vehicles. And so that idea of reusability, the reusable first stage and crew capsule that we've developed for New Shepard, has informed now a new vehicle that we announced a little over a year, or a little less than a year ago, called New Glenn. So New Glenn, which you see here, is an orbital launch vehicle designed in a two-stage configuration to launch about 45 metric tons to low Earth orbit. Reusable first stage, using the lessons learned and the approaches that we practiced in New Shepard. So it's a pretty exciting time for New Glenn. And a lot of my colleagues are working very hard back in Washington State and other places to get this system up and running. So we have a 2-stage version of New Glenn, and then we are also looking at a 3-stage version, 5.4 meter to 7 meter fairing. That will be a very exciting addition to the world's launch vehicle fleet. And we are actively now selling this vehicle as well. We have announced a commercial launch contract with Eutelsat, as well as a contract agreement with OneWeb. And so it's a pretty exciting time for the company, both in New Shepard and New Glenn. We're also developing engines for these vehicles. We do develop a lot of the systems, technologies in-house, mature them. This is a picture of our BU4 LOX LNG engine, 550,000-pound thrust that we have designed, developed, manufactured, tested, or will test here shortly in an integrated fashion. And so it's pretty exciting at the factory to both have New Shepard and New Glenn kind of maturing, and to see the designs and the technology that the company's been working on come together in these vehicles. We're also looking at future concepts, and part of my job at Blue Origin is to look at the future scenarios of the company and what we might want to do with the technologies that we've developed. So a few months ago, we talked about a new initiative we call Blue Moon, which is a lunar lander architecture to land up to 10,000 pounds to the lunar surface. So we believe it is time for America to return to the moon, this time to stay. And we have some of the technologies using our vertical landing technology, LOX hydrogen stage technology, that can enable this future that we think is a first credible step on the road to a larger, more permanent settlement on the lunar surface. So we're very excited about exploration. We do believe the moon is in sequence on the way to other places in the solar system. And it's a pretty exciting time that we are now at scale to be able to engage in these kinds of endeavors. So I look forward to any questions on the panel. Thanks.
Great, thank you, AC. So you can see we have quite a broad spectrum of talent and applications here on the panel. So I wanted to take this opportunity to just ask a few questions, and then we'll open it up for the audience here. So, you know, following up on your comments there, AC, about Jeff Bezos's, your boss's vision for what he saw in space, and I thought the other thing was intriguing, the fact that he had this, not something he came up with last week, but the fact that he announced this at his valedictorian speech when he was a senior in high school. I thought was really neat. And so, and it certainly got me when I heard it. It said the vision of millions of people living and working in thriving communities beyond the Earth. Heavy industry and resource extraction will be moved off planet, and the Earth will be zoned for residential and light industrial. So I just thought, wow, that is a really cool vision for the future. So I assume that you bought into that, or you wouldn't have joined the company.
Yes.
But for the rest of you, I was just wondering what you thought of that vision, if it was achievable, and if so, what do you think are the key elements that will enable this vision to become a reality in the future?
Yeah, I'll happily take a stab at that. It's going to take several steps to get there, and clearly some people have
Joel, the mic a little closer. Okay.
Clearly some people have the roadmaps. Manufacturing, in space, fuel depots, all of these elements mean that there needs to be the infrastructure, not only for development, but also for the continuation and advancing life, until we can start to create the environments on other planets that allow food and water and all the things that we consider necessities, right? In order to make another planet, or even just a space station, fully habitable. Right, I mentioned our Accion project as something in the near future. It's going to take a little bit of time to build that out from a research facility into a commercial facility for manufacturing pharmaceuticals, materials, and all the things that are part of that infrastructure. So I see it as a stage by stage, but clearly we're all working together to make this a reality beyond just the dream that we can do this.
Natalya, do you get any comments on that? You showed some really kind of cool pictures there that for your vision for the future. So
Yeah. Well, I believe it's achievable and hopefully a stepping stone on the way to the broader vision of people living elsewhere in space, because I would hate to zone all of space for manufacturing and then
Yeah.
just live on this tiny little part of it. But I do think, humans are actually one of the places we need to work on to enable this. So keeping us alive and well in these different environments, we're kind of a weak link in this plan that we'll need to address.
So Tom, let me kind of rephrase that a little bit for you, because you guys are in kind of a unique position. You've had a pole position in this for the last half century. You guys gave us a great ride. My first space mission was Pioneer Venus Orbiter back in '78, and we got a great ride from the Centaur and the RL-10 that you guys developed. And now, there seems to be this tsunami coming through and changes everywhere. How is Aerojet trying to respond to that? And what role do you see your guys playing in this new future?
Yeah, I think we gotta leverage our strengths, and part of that strength is our experience and our heritage. And the RL-10 is a great example. It's an engine that has been used across multiple platforms for decades. And what we're doing right now with that engine is we're bringing in new technology, specifically additive manufacturing, to bring the cost of that engine down by 60% while maintaining the performance and the reliability. So that's kind of our basic approach. Is we got to leverage what we're good at and leverage the new technology to make it more affordable. Like I said, ISPs, chemical ISPs are not going to change a whole lot. We're not going to do a whole lot better. It's how do we make them cheaper and make them better from a reusability perspective. How do we get inspections out? How do we make them more robust so that we can turn things around quicker? From a broader perspective, I want to live in space. I think humanity has to live in space. I think what we haven't solved is the chicken or the egg question of, I need the infrastructure in space to do stuff, but that infrastructure is so expensive. I hear a lot about, the use of space resources, but mostly the customers come back to being the people who want to operate in space. So we got to figure out how we break that cycle of, what do we do in space and how do we make it cheaper? And I don't think anybody's quite cracked that answer. If you look at why people have explored in the past, it's because, one, they felt they needed to leave, or they felt they could go out and bring something of value back. And so I think, from a humanity perspective, what caused people to go out before, and how do we emulate that again? I think the governments are still, for quite some time to come, going to have to be the enablers of that. I think the commercial market will help, but the governments still need to lead where we can't justify a strong economic justification right away.
So AC, your boss, Jeff Bezos, has talked about being one of the providers of that infrastructure for the future. And I got an interesting factoid on the radio driving up today, was that apparently this is the anniversary in 1956 when they signed the Interstate Highway Bill in the Eisenhower administration that built 42,000 miles of interstate highway in the United States. And Jeff is talking about, building this highway system or this infrastructure system for space. How do you guys see that evolving, and what role does the government play in that?
Yeah, so I think for us, this vision of millions of people living and working in space, is enabled by this foundational aspect of Earth to orbit transportation that is very accessible and very affordable. And so that's why we've made an effort, and a large effort in New Glenn, to leverage the lessons we're learning in reusability on New Shepard, get the prices down for New Glenn to enable this foundation of Earth to orbit access. Once you're there, we were also thinking about how to reduce the cost of getting to other places in space, in cislunar space, for instance. I think Jeff's ultimate vision is to enable many things to happen in space, a la the foundation, the start of the internet revolution, and what we see now from 20 years ago. When Jeff started Amazon, there was a foundation of TCP/IP. There was a foundation of browser technology. There was a foundation of electronic financial transactions for the average person. There was a foundation of FedEx, UPS. All that was there and enabled, and Amazon did not have to invent that. And at Blue Origin, what we want to do is enable affordable, responsive space access and then access to other locations, so then people who have ideas for resource extraction, ideas for other types of resource utilization can be enabled. And all those great ideas that people in this room and outside this room have are enabled by the space transportation elements and other elements that we're thinking about. I think launch is the first key that we're trying to solve, and then we've got other ideas in the future of taking that forward to other locations. So people might have great ideas to do stuff on the lunar surface, and part of that would have partnerships with the government. So for instance, our Blue Moon initiative, we have discussed that with NASA, and we have identified areas of assistance that the government can do. We have had commercial space act agreements with NASA, for instance, so the government can be a very credible partner in helping look at our systems. There are technologies within the government that we can leverage and partner with, and I think there's a nice synergy with the various technology developments that are out there, both in transportation, infrastructure, and other elements that could be helpful to us and others. So.
Very cool. I think it's important to remember too that this whole thing started. I remember reading something the other day that it was only 22 years ago that that Jeff was talking about that there was 10 people in Amazon and he was driving the stuff to the post office himself in his van. So that's quite a remarkable growth rate for 22 years. So let's kind of put on our dreamer hat here for a minute. And one of the things is we've talked about a lot of interesting things. We've talked about mining the moon for water, and we've talked about Earth imaging, and we've talked about space tourism and everything. What kind of new industries, let me put on your creativity hat. What kind of new industries or potential do you see out there, and let's say over the next decade that you think might be one of those sleeper ideas that would surprise everybody if we got together 10 years from now and we were looking back and say, geez, who would have thought that would have turned out to be such a great idea? Anybody want to tackle that one?
I don't know, I guess if I had an answer to that, I wouldn't tell anybody. I'd be trying to go raise money.
Yeah.
In some sense, maybe I don't have an answer to that, but the way I think about it, going back to my previous answer, is that if we can enable this future, I think I'm less concerned about what is that exact idea than being able to make sure that whoever has that idea can get to space and execute that rapidly and very affordably. If we can solve that problem, then there'll be more people coming into space outside of this community that we currently have in the space industry that will be attractive because they say, getting to space is really cheap. Getting to space is really affordable. I never thought that was possible, so I want to do this or this or this. And so I think if we can solve some of these problems of access, that these great ideas that are nascent in our world, but that people feel they can't execute and get to space, and those things will happen. So I don't know, it's not a good answer, but I think if we enable that future, more people will come into the industry with great ideas that might find that killer app.
Well, once the cost is low enough and space tourism kicks in, I'm thinking of resorts in space, a space spa, that sort of thing. These are the sorts of things I pictured. But the far out idea that struck me was, since healthcare is on everybody's mind these last few weeks, is that there may be therapy centers in space that serve large communities for recovery, for particular types of surgery, or suspended animation that allow people to live another day. And I kind of see that as a little bit far out there, but maybe that's the piece that surprises us when transportation is low cost.
Well, one of the things that Heinlein talked about in one of his books was the idea that if you look at the aging process, that one of the big tyrannies of the elderly is gravity. And so if you could, maybe you don't want zero gravity, but maybe a little bit of gravity. So he was postulating that the moon would be a great place to retire to because you got enough gravity that stay where you put them, but that a fall isn't fatal. You know, it's not, you're much less likely to break something. So I just always thought that that was a neat idea. And I loved his idea that if you were on the moon and you filled a cavity up with air, that you could strap on a set of wings and fly like a bird. I always thought that would be a really cool thing to do if any of you read The Menace from Earth.
That I can hit a golf ball a couple hundred meters.
Right.
You know, while I'm crippled and holding a cane. That would be perfect.
I think that goes to the idea. I think Jeff has also talked about the element of surprise. In exploration, many times you also want to explore in areas where there'll be surprises. And so the lunar surface, as you've just mentioned, could be an area of once you're there, all these things, in the last 30 seconds that you've mentioned, you know, and there'll be more things you could do and more surprises. So I think that that really energizes us in terms of when you go to a destination, the kind of the unknown elements that could be surprising, that could be the new app or new application or whatnot.
Because that could put the extreme in extreme sports too. You know, if you were surfing a lunar dust hill rather than or doing something on Mars. So let's talk about disruptive technology. So we've been talking about evolution of existing technologies and things like that, rocket engines and life support systems and all that. I was reading an article this week about, in one of the blogs, and they were talking about Sonny White's EM drive out of the Johnson Space Center that they're postulating. And so far they've been able to get about this much thrust out of this thing, but they were talking about if you could scale it, how much power would it take, at various Q factors to do this? And it was amazing to me that they were postulating that with reasonable powers in the, gigawatt, range, a lot of power, but, not in inordinate amount of power. We've done that, here on Earth, that you could basically accelerate a 1 ton or 1,000-ton vehicle at 1 gravity. And I thought, wow, that would be something. Now, again, this not clear that the scales or anything, but it brought up this whole idea. So we've been talking about disruption in a lot of technologies, but what about disruption in disruption? So disruption squared or things like that. So for those of you guys that are trying to develop these new technologies, how do you look at the people that are trying to disrupt your disruption? Does that make any sense? Apparently not.
We don't worry about the competition.
Well, I think it's. I think part of that is maybe less external and just both the leadership of a company, and I've experienced this in several companies, and so I think it is if the leadership gives you a very audacious goal, if you have a very talented workforce and you have the resources, that can go a long way, and I think that in some sense is like the internal teams, management teams pushing the company to excel, and excel rapidly. But at a very smart pace. So I think, and that way you can with that kind of enlightened management, you can try to keep ahead and a step ahead of the competition or other external factors. So I think that's also probably important beyond looking outside, just how a company and leadership kind of is using the workforce.
So the EM drive, that's directly competitive to what we're doing, but I think ultimately we come from a place of wanting to see the industry develop and see people off the planet, and anything that moves that needle and helps move humankind towards that goal is always a positive. I would like to see this particular one fly. I think NASA's going to be launching it, so we'll see how that goes. And then, we have, last year probably even at this conference, I'm not even sure we had any competitors other than maybe 1 or 2, and now there are like 15. So the way we think of that is just listen to our customers and build what they need and do it quickly.
I think, our company's focused, in terms of advancing TRL, it's all about the in-space. As I mentioned, I think launch propulsion from a performance perspective, we know where we're at, and it's all about getting cost out. It's the in-space element where I think there's a lot more technology to explore. That's where we're very focused on solar electric propulsion. We're resurrecting and looking harder again at nuclear thermal, particularly for human space transport, because it is high thrust. With the EP systems that do, very low thrust, take longer, but for things like cargo, that makes sense. For trips to Mars, you can pre-position your cargo years in advance and then send the humans quickly. But we're definitely looking at the in-space portion of the overall transportation architecture is where the technology really needs to be pushed forward.
I think again and again we're going to encounter disruptive technologies. It's our nature. And in welcoming that and embracing that, we both advance the industry and ourselves. What's really important to understand is that this is a very complex industry. The brain power in this room alone can put people on the moon, can put people beyond, and have. But the user experience is inaccessible for a number of early entrants, and trying to reduce the friction and accessibility for new entrants in the marketplace, not create barriers of cost or physical barriers. Reducing that friction is really kind of incumbent upon us, the smart people, to do that, right? Make things easy so that we can go to the next step faster, right? Make the user experience advance. Push one button and you accomplish what you need to do. Don't take 6 months of very lengthy steps of involving hundreds of human beings, right? Don't reinvent the wheel. We need to do this faster, and it is, I narrow it down to the user experience, but we all know what that means for our industry.
Yeah, I remember talking with Richard Garriott, and he was talking about his experience in flying to space, where he not only had to go to Russia for 6 months, learn to speak Russian, but actually to pass his physical, he actually needed to have major surgery done in order to do this, and so he showed us all his scars from that. So that's a pretty tough kind of thing to do. So if you could make it easier, you go and stay a day or two and have a good time and have a really nice user experience, and then you go do it, and you're spending a few days or maybe a week versus spending 6 months of your life and all that. I think that could make a big difference. Okay, let me open this up to the audience, and remember, we can't see a thing up here, so if somebody could help out with the microphones and all that. So hopefully you guys have got some good questions that are going to keep everybody awake.
Hi, great panel, Luke Maloney. I wanted to ask you about the R in TRL. I'm wondering if you guys are imagining any particular industry which could be enabled by some disruption in re-entry. I can imagine human spaceflight, backhaul for manufactured goods and so on, but maybe you know of something else.
Anybody want to check that?
I don't know what the physical barriers are to re-entry or lowering the cost of re-entry, but certainly that is becoming increasingly important as I talk to larger and larger customers, right? Past the point of experiment, now we need to down mass materials on a very commercial level, right? Whether that's pharmaceuticals or chemicals, it needs to happen. I just don't know how, and I don't know what the barriers are, and I would quickly point to my colleagues at Blue Origin to solve that problem faster than me.
Thank you, yes. No, I think that is part of this whole ecosystem of industrialization that Bruce kind of started the conversation on. That part of what we're trying to do is obviously, make things more efficient from space resources, but at some point also bring stuff back down. And so I think that's, we're really focused on getting stuff up there a lot more affordably right now. But also, us and others, or the industry has to figure out, once infrastructure is there, things are developed, things are manufactured. Hopefully we can use that to help folks back here on Earth. And I think as others have said, there's more, hopefully at some point there's as much stuff coming back down as going back up, as going up. So, that'd be an incredible future. And that's, I think, part of this future we're talking about, that there's a synergistic relationship between the folks on planet Earth and all those folks that are out there in cislunar space.
So one of the things our center does at Ames is we do reentry materials. We have a whole division of people that work on that. We have the Aerojet for being able to do this. So there are a lot of materials research going on to look for new and better materials for that. I think one of the things that was surprising how well it worked was Elon's hypersonic retropropulsion. A lot of people had talked about that, and a lot of people had dismissed that as impossible, and which just goes to you, sometimes you need to go try stuff. And son of a gun, it works. As we saw last weekend, that they had a couple of over a 3-day period, they had 2 launches and 2 recoveries of the first stage. Okay, any other questions? Yes.
A question for Blue Origin about the economics of reusability. At a flight rate of 1 per year, presumably the economics don't close if you have to keep a manufacturing capacity around doing nothing. At a flight rate of 1,000 a year, it probably does make economic sense, because you can keep your manufacturing people operating at some sustainable rate. Have you done a study that determines what the crossover point is in terms of flight rate, that where the economics work? Or to put the question another way, are you aiming for a certain flight rate per year?
Yeah, I think at Blue Origin, yes, we do have extensive models and analyses we've done of various flight rates and architectures and reusability rates that has gone into the development of the New Glenn launch vehicle. So yeah, I can't be too public about some of those more confidential studies, but yeah, so we have done the trade studies. Jeff is very, would like us to be and focus on the commercial market and to focus on being a self-sustaining enterprise. So we have looked at that, and that's what you kind of see as an output of the New Glenn launch vehicle in terms of payload, and we have our own aspects of the numbers of times that booster and engine can be reused. So yeah, so we have looked at that.
Any more questions? So I've got one question that for you guys to kind of to close this out, and that's, if you could change one thing about the ecosystem that you thought needed to be changed, whether it was regulatory or whatever, you can't change the gravitational constant, but something that actually might happen. Is there one thing that you think that would really help move things forward, either from a supplier or demand or a technology point of view?
Yeah, I heard someone on the government side mention that, they think the view of the government and maybe NASA in funding development, they've reached, as far as they need to go, and the commercial side should be on its way. And I think maybe that's true if the end goal is a commercial ecosystem in LEO and GEO. But if the end goal is, bigger, like we've been talking about here today, I would love to see more participation, maybe for a little bit longer.
Ron, you got to have an opinion on this.
Grumble, grumble. The regulatory friction, right, but is something that has a hidden cost for a number of entrants, right? And so when I see the frustration on a group of 3, right, who come to me with the technology and a significant cost burden for whatever technology they're introducing, right? Earth observation, whatever the case is, manufacturing in space. It sets them back, right? And more investment would help, but that's not the milestone that any investor is looking for. So it's almost like we need a little bit more latitude from the investment community to accept that these things take time and that the hidden regulatory cost is just part of doing business. And also from the overseers to recognize that maybe there's something to be gained by reducing the amount of paperwork or time that these things take. But yeah.
Well, I kind of echo that point from an investor standpoint. You know, I think as a technological society, we've come to expect Moore's law for most of the quote technology we use, but you know, space access is not governed by that same rule. You know, the physics of getting into orbit they're not changing. So I think maybe we have a false sense as a community of how fast we should be moving and how fast this technology should be developing. So I think if there was more realistic expectations of how hard this is and how long it takes, maybe there'd be more stable investment. One of the things I've started to wonder about is specifically with Blue Origin, whether from a community standpoint, Blue Origin is good for the rest of the startups because they operate on a completely different economic model, being highly self-funded and be able to do things that most of these people in the room simply don't have the investment capability to do. Is that good for the overall community? How much can one billionaire really do, and does that provide a false sense of progress for the rest of the community? I don't know the answer to that, but that's one of the things I've been thinking about recently.
I'd say no. I think it doesn't.
We're shocked.
Yeah, no, I think yeah. For me, it goes back, and it's a good question. For me, it goes back to this idea I was saying that if we are successful at Blue Origin, and other folks like SpaceX are also successful, and I have friends that work there, and I wish them success. I think we will enable this future. I really think it's this access. This idea, the people that come to you at NanoRacks and other folks that want to get to space, you've enabled great things on the ISS. And I think if we're successful, we can also enable those same people to go to other places in LEO and other places beyond if we can reduce the cost of space access, I think. So I'm pretty excited. I think the other thing I would say is something that I think my colleague Erica Wagner, you probably have all heard her say, is growing the pool. Growing the pot. Growing the pool of people that are engaged in space. There's like I said, I think what's also kind of missing and would help would be other industries, other companies that are not using space, whether it's mining, photonics, whatever, bioengineering. Those companies coming in and telling us where they want to go, the price points they want to pay, what's important to them in terms of responsiveness. NanoRacks has done a great job engaging, and Casis and others have done a great job engaging with those new communities. I think that to me is pretty exciting. It's great to see all my friends that I always see every year at NewSpace, but it's always exciting to see some of the new folks from non-space companies that come here. That to me is part of, I think, the success of this conference is to bring those new voices in. And that kind of energizes me. Some company I didn't know of that's, not a space company but wants to get to space to do something. That to me is really exciting, And if we're successful, us and others, we're going to get that cost down, get the responsiveness to a very great point. So it's no longer, can I get to space? Is there even a possibility? Yes, I can. It's just one of many things I can do,
Cool. Please help me thank the panel.